understand. So this is integrated circuits. So guys, look here, the pictures of the ICs. What is a IC? ICs are basically called integrated circuits are usually called as ICs and popularly known as silicon chip, computer chip, or microchip. Then maybe you have heard these names. Okay, so this is called integrated circuit. So how it looks like, you can see now. This is a picture of the IC, and here we have the legs of this, which is used to connect the components which is inside it. Okay, so this is 1 2 3 4 5 6 7 8 9 10 11 12 13 14 14 this side and 14 another side. So 48 28 pin IC, like 1 2 3 4 8 pin IC, 16 pin IC, and all. So different pins they are having, and this is used. So now IC, tiny electronic circuit used to perform a specific electronic function. They are basically designed to perform a specific function, electronic function, such as, for example, amplification. So we have a signal, we want to use it to amplify the signal strength. We use it for that purpose. So you may know, you may have seen this type of radio stations, which is used to, catch the FM signal and then play the sound. So this is the transistor. We called sometimes it is transistor. What is a transistor? Basically, it is an amplifier which basically amplify the sound signals. And we have a speakers here, which we can, which is used to which is a output device. Okay, it is usually combined with the other components. So it alone IC is not a complete unit. It is used to combine with the other components as well, so to form a more complex system. Okay, several hundred identical integrated circuits are made at a time on an thin wafer several centimeters wide, and the wafer is subsequently sliced into individual ICs called the chips. Now you have heard this name wafer. What is this wafer? Basically, it is a slice of the semiconductor material. We have discussed about the semiconductors, silicon, germanium, and all. So first, these materials are cut into the form of a wafer, and on that wafer, ICs components, transistors or diode, these things, components are fabricated on the tiny, and you can see how tiny this wafer is. There are, if you can just see these dots, so they are components here. It could be a circular shape, it could be a square shape, and all like that. So this is something about the ICs. Now let's see the type of the ICs. So how many types of ICs are available in the market? So in early days, the integrated circuits, only a few transistors. What are transistors? You will see this thing in the next chapter. It is basically the extension or upgraded version of the diodes, PN junction diode. So in PN junction diode, we have PN N-type material, but transistors are having two layers, like NPN or PNP, like that. So we'll discuss transistor in the next chapter, inshallah. So only a few transistors could be placed on a chip, as the scale used was large because of the contemporary technology, and the manufacturing yields were low by today's standards. As the degree of the integration was small, okay, at that time, yani less number of components can be designed. Early days, less number of components can be designed on a single chip. The design was done easily because of less number of components you want to design. So designing was easy. Over the time, millions, see this, millions, and today billions of the transistors and electronic devices, semiconductor devices of transistor could be placed on one chip. I give you example, A14 bionic chip, which is used in iPhones. It is having billions of transistors around, I think, if I'm not wrong, 11.4 billion transistors. So, and to make a good design become a task to be planned thoroughly. This gave rise to new design methods basically. So it's about the ICs. So ICs are often classified by the number of transistors and other electronic component they contain. How we classify the ICs? We classify the ICs according to the number of transistors, okay, and the components it contains. So SSI. What is SSI? Small scale integration. So in this integration, up to 100 electronics components per chip can be designed. Electronic components, or we can say number of transistors, can be designed. Then next generation comes, which is called MSI, medium scale integration. So from 100 to 3000 electronic components, okay, per chip can be designed in this technology. The next technology comes, which is LSI, large scale integration. And here 3000 to 100,000 electronics components per chip could be designed. But still, technology is not stopping. Next, VLSI, very large scale integration. So here 100,000 to, you look here, how much? A million electronics components per chip. ULSI still, continues. Ultra large scale integration. More than 1 million electronic components per chip could be designed in ULSI, like billions and all. Okay. So this is the integration and the classification of technology: SSI, MSI, LSI, VLSI, and ULSI. Okay. So integrated circuits can be classified into the broad category is like that. The type of ICs. It could be analog type, or it could be digital type, or it could be a mixed signal type ICs. Both analog and digital on the same chip. If we say mixed signal, yani both analog and the digital on the same chip. So three types: analog, digital, and mixed signal ICs are available in the market. So what are the advantage of the ICs? Okay, the advantage: very small size. This is the one advantage, because it's not taking much space in your system. Low cost, because it designs as a mass production in the factory, so the price is less, cheaper compared to the discrete components. Reduce power consumptions, because circuit is so complex, and signals are travel very less distance, so it have reduced power consumption. Highly reliable, highly operating speed, the speed operation is very fast. Reduce external wiring connections, because internally the components are connected, so it reduce the external wiring connections. Easy to use, just connect and just use it. These are the advantage of this. So questions may come. We can ask you which one of the following is the advantage, which is not the advantage. So these things or information are important. Now see the disadvantages. So disadvantages of the IC. If one component in an integrated fails, that means the whole circuit has to be replaced. This is the problem, because we cannot replace any particular component in the IC, because it is designed so close, as you can see that millions and billions of components can be constructed. So it's so difficult to repair the any faulty component. So if one fails, complete IC need to be replaced. This is the disadvantage. It is possible to fabricate transformers. It is possible to fabricate transformers or any other kind of inductor onto the integrated circuits, and again calling for discrete circuit. Okay, it is impossible basically. Sorry, it's not. It is impossible to fabricate transformers, because for the transformers we need, magnetic, the path to flow. We need a core and all. So and the size of the transformer is very big, so we cannot design it is impossible to design the transistors on the IC. Third thing, integrated circuits have limited capacitances. Okay, this calls for external component if the capacitance need to be extension. Yani, if we have a IC where we are the capacitors, so capacitor size is limited. We cannot have the large capacitor because you know that the value of the capacitors depend upon the plate size, the area of the plates. So because IC means that, in short area, we have many components. So we cannot use it. You can design, large value capacitance in the IC. Power that integrated circuits can produce is limited. Again, the power which that can produce is it is limited. We cannot cross that power, which is, there is a limitation of the power. So there are few disadvantage of the ICs compared to the many advantages of the ICs here. So any one of them can be asked in a multiple choice. So you need to go through it. One of them, integrated circuits are not flexible. Yes, because of the first point, we know that if anything, any component gets fail to work or damage, we cannot reuse that IC. So this is the point, that integrated circuits are not flexible. Their components cannot be modified and neither can be parameters of operation. So once it is designed in the factory, during the manufacturing, whatever components, we cannot change it, we cannot modify it. So it is not flexible. Next thing comes here. So this is about the ICs, guys, ICs technology. Next thing is optoelectronic devices. Okay, have you heard this name, optoelectronics? If no, I think you know about the opto, and you can understand the separate word electronics. Opto, yani it is related to the optical, okay, light, and electronics related to the electrons, flow of electrons. So opto basically yani optical, which related to the photons, the light, electronics, yani related to the electrons, flow of electrons. So we are going to discuss now optoelectronic devices in few slides. So content, what you are going to discuss here, and see this introduction to the optoelectronics. So optoelectronics is the study and application of electronic devices that source, detect, and control light. What they do? They source, they detect, and they control light. Usually consider a subfield of the photoelectronics. Yeah, photonics, what you call photonics, okay, subfield of the photonics. So optoelectronic devices are electrical to optical, or optical to electrical transducers. They basically use to convert electrical signal to the optical and optical signal to the electrical. When we say electrical, it means we are talking about the flow of electrons. When we say optical, any flow of photons. So these devices are used to convert electrons to the photon and photon to electrons. Okay, or instruments that use such devices in their operations. Electro-optics is often anonymously used as a synonyms, but it is in fact a wider branch of the physics that deals with the interactions between light and electric fields, whether or not they form part of the electronic devices. Okay. So look here, image of the optoelectronics. Have you seen these type of glowing LEDs? Some wire, there are a lot of lights, they are glowing, maybe some functions, maybe some shops and home and cars. You can see this one. So these are the simple LEDs basically. So we connect to the source. Source is what they generate the electrons. Electrons flows there, and the electrons is converting into the light. That's why we said electron to photons and photon to electrons conversion are there in photoelectronics. Important optoelectronic devices. What are these? Very common. LED. In short, what we should call LED, but it is a stand for light emitting diode. Then what we have? Photodiodes. What we have? Photovoltaic devices, or what we call solar cells also, and laser diodes. So we are going to discuss, just see this one by one, some detail. What are these basically? LEDs, light emitting diodes. So LED is a acronym for light emitting diode. It is formed by forward biased PN junction. When electron in N-type semiconductor combine with holes in the P-type semiconductor, they release energy in the form of light or heat. You look here, guys. So we have P-type material, we have N-type material. They are specially designed, actually. You know, the difference is the normal diode, PN junction diode, and this LED. They design in a way when you connect them in a forward bias, so electrons whole start combining, and then we provide an space here so that they can comes out from that one. So we have a here the way it is designed in a way that electrons can come out so that light can emit. But in PN junction diode, we have no mechanism that the electrons can come, these photons can come out. So this is the concept. So recombination of free electrons and holes here, free electrons are there, and then it is releasing the photons, which is basically creating a light. This is the construction of the LED in detail. This is substrate, the very first layer, guys. Then we have N-type material. Then we have active region, where they combine, we call active region. And then we have P-type at the top. So P, active, N-type, and then we have substrate. And then when we connect to this in forward bias, what happens? Electrons and holes start combining, and they start releasing the emitting photons from everywhere. So this way it is basically start glowing, the LED. Symbol of the LED, you can see it is very much similar to the symbol of the diode, except the arrows which is directed outside. You can see these two arrows. So it is the symbol of the LED. Okay, because it is a diode, but it is a LED light emitting. So the arrows are the different. It is producing the difference between the symbol of the LED and the diode. Is it clear? Are you getting on? The difference and the construction. Any related question? If you have, you can ask. And this LEDs come basically in a different colors also. So red, yellow, and different colors are available. Depend upon the type of material we use, we can have a different color. Any question, guys, here, or is it clear to all of you? Okay. So this is about the LED. So you need to read it. You need to understand it because we can ask the basics questions from this here. Next. Photodiode. It is again important. Please focus now. So LED. Okay. If I ask you how the LED is working, so you can simply say, sir, yes, it is working like the electrons are coming from here, and these electrons and holes are combining in this area. So basically, in general words, we can say electrons are converting into photons. So what is the LED? LED basically is a transducers which basically converting electrons into photons. See the opposite operation in photodiode. So what is a photodiode? It's accepts the photons, yani light, and convert it into electrons. Okay, see now, read the what is photodiode. So the photodiode is an PN junction under reverse bias. See, how do we use it? We use it in a reverse bias. In a reverse bias, exposing a semiconductor to light can generate electron hole pairs. So if we expose the semiconductor to a light, it can generate electron hole pairs, okay, which increases the number of free carriers and its conductivity. You look here. So first, what is a photodiode? It is a diode which is work in a reverse bias. So we connect in the reverse bias. So because of it, what happened? The depletion layer become widen. We discuss about it. it will be wide. So this region we expose to the light. So whenever light falls on this depletion layer, you can see this green photon strike on it. So it releases its energy. So one photon, when it strike to the semiconductor material, it gives the energy to the electrons there. So what happened when it strike to that, it causes two electrons move. So when electrons move, it generates electrons and hole pair. So if you read this one, exposing a semiconductor to a light can generate electron hole pairs, because light energy is converting to the electrons energy now, electric energy. So which increases the number of free carriers, and it start conduction. So electrons will move to this side and hole will move to the another side, and then it start flowing the current. So a photodiode is a semiconductor diode that functions as a photodetector, which is used to detect the light. It is an PN junction or PIN structure. Pin, P-type, intrinsic, yani pure semiconductor, then N-type. When a photon of sufficient energy strikes the diode, it excites an electron, thereby creating a mobile electron and a positively charged electron hole, which is something. So this is the operation of the photodiode. Look the symbol, similar to the LED, but the difference is the arrow direction. It is inward, so that it shows that the light will fall on it, and it is basically a photodiode. For the LED, it is outward, okay, because it is generating the light, but it is accepting the light to generate electron hole pairs. Okay, this is photodiode, guys. Any question or clear? No question? Clear, na? Photodiodes? Okay. So a photodiode can be operated in one of the two modes. We can operate it two modes: photovoltaic mode or photoconductive mode. What is photovoltaic mode? In the photovoltaic mode, the photodiode is unbiased. Yani when we are using this photodiode in a photovoltaic mode, it is unbiased. Yani we are not connecting any external battery. In other words, no external voltage is applied to the photodiode under the photovoltaic mode, which is basis of the solar cells. This concept used in the solar cells. Understand? We don't need to connect any external source. It is the basis of the solar cell. Second, photoconductive mode. So in photoconductive mode, an external reverse bias voltage is applied to the photodiode, which we have discussed in the previous slide. In a photovoltaic mode, we use in the solar cells. Okay, these are the two modes of the photodiodes where it works. Now, so key difference between the LED and photodiodes is again important. You can just read what is the difference between LED and photodiodes. Function. The function of the LED and photodiodes is contrasting. LED emits photons due to electron hole recombination, while photodiode provides energy to electrons and hole by exposing itself towards light radiation. So opposite operation. Operating principle. As we have discussed above, the operating principles of LED and photodiode is also different. The principle of which LED works is called electroluminescence. That is illumination using electronic charges, while the photodiode works on the principle of photoconduction, which means conduction using photons. Biasing. Third, LED always operate in forward bias mode, guys. It cannot be operated in reverse mode. It will destroy it otherwise if you use in reverse bias. A photodiode is a device which operated in reverse mode only. So photodiode is a device which operated in reverse mode only. Conversion from conversion form of energy. LED converts electrical energy into light, and photodiode converts light energy into electrical energy. Material use: LED made up of gallium arsenide and phosphorus, GaAsP or GaP, gallium phosphide. So germanium and silicon semiconductor are not used in the manufacturing of the LEDs. We don't use this germanium and silicon. We use it for the PN junction diode. For the LEDs, we use these materials, GaAsP or GaP. Photodiodes are made up of germanium and silicon semiconductor. But on the other hand, photodiodes are made up of germanium and silicon semiconductor. So you need to go through it to understand the difference. So the photovoltaic device or solar cell, guys, how it works basically. So photovoltaic device, any one of the mode of the photodiode, photovoltaic device or solar cells are semiconductor PN junction that can convert solar radiation into electrical energy. So how it works? So this is a single cell and it is made up of a module which called module. There are many single cells, and then these modules are form of multiple, then we have these type of arrays. So photovoltaic modules, panels, this is called panels, and arrays, like that. How it works, the working operation, how it works. So this is a cell, this is a sun. So sun radiation is falling on it. So it is working in a photovoltaic cell. This is the electronic circuit. So here for fast forward drop n-type silicon layer, and when the light fall on it, so this photons energy, okay, or light energy converts here electrical energy, and which constitute the current in the circuit, and which is going to use it to glow the light or to do another thing. So this is the blow diagram which can help you to understand. Energy source is the sunlight, which is falling, which we are falling on the cells, and here we have energy conversion. So this energy is converting light energy to the electrical energy by means of these cells or photovoltaic cells. And then we have energy inversion and conditioning. So we use it for we convert this energy for conditioning this one, so that we can store this one. So then we store this one, energy storage, we can use a battery to store that one. Then once we store it, we can use to distribute this energy. Okay, we can energy use and electrical utilities and all. So major photovoltaic systems components are here. So this is with this diagram, you can understand how this photovoltaic devices or solar cells basically works. So next is the laser diode, guys. Laser diode concept. What is the concept? For automatic system in thermal equilibrium, emission of the light is the result of two main processes. So the emission of light, basically there are two main processes. First is called absorption of the light, spontaneous emission of energy. A random photons is emitted, which is in case of LED. A third mechanism is crucial to formation of laser action, which is stimulated emission. You have studied this emission in the physics. I know that it is there. So this three absorption is spontaneous and stimulated emission. So what is a laser stand for? It is basically acronyms of light amplification, of stimulated emission of radiation, emission of radiation. This is the mechanism of the laser. So what are these things? Absorption, spontaneous emission, and stimulated emission. So here in absorption, what happened? Whenever a photons of energy h nu strike, so what happened? It's give the energy to the electrons, and electrons from the lower energy state jumps to the higher energy state. Okay, this is the concept of the absorption. But in spontaneous emission, what happened? Any whenever because once the electrons get enough energy to jump to the higher energy states, so it cannot be stay here for a long time. Electrons cannot stay in the higher energy states for a long time. So what happened? After some time, this electrons comes back to the lower energy state. When it is coming back down to the lower energy state, it releases the energy or in the form of photon, okay, and h nu, which is the band gap energy equivalent to that one. This is called spontaneous emission. Third thing is stimulate emission. So here, what do we do? Basically, in this emission, first we pump the electrons from lower energy to the higher energy. So electrons are in higher energy state. Now, the photon of h nu energy strike on that electrons which is in the higher energy state. Because of it, what happened, it is start falling down. So when the, as I explained to you, when the electrons cannot stay in the higher energy state for a long time, when it is coming back to the lower energy state, at that time electrons strike on it, and then it creates multiple photon, one photon creates two photons. And then here we have a concept of the mirror, so that they multiply, so that one photons will generate two, and two will further generate four, and four will generate eight, and so on. So here is a concept of photon multiplication. And guys, the thing, another concept of laser is that all the photons are directional basically. That's why if you notice that whenever you use these lights, so laser lights, they are pointed in comparison to the LEDs. LEDs, scattered light everywhere, but laser light is basically directional, okay, and it is used to point, a very sharp point. And the advantage, the use of the laser, they are used um, uh, basically for the cutting tool also, and lot of major application in skin diseases, and hair implantation, and what is that, for the beautification, yani skin and all. So there are a lot of medical application of the lasers basically. So three operations: absorption, spontaneous, and stimulation. And already you studied these things in physics. So diode lasers have been used for cutting, as I said, cutting, surgery, communication, optical fiber, CDs writing and reading, etc. It is used for all these purposes. Advantage of photoelectronics now. Compared to copper wire, optical fiber cables, optical fiber. Have you heard about this name, optical fiber? Maybe you are using internet at your home. Optical fiber. So, okay, the signal which travels in these optical fibers are basically the light, the laser signals, light signals flows through it. So compared to the copper wire, optical fiber cables are cheaper, less weight, and provide more bandwidth. Also, it is free from hazards, because in copper wire, if you touch the naked wires, you will get hazard. Okay, hazard. It's a dangerous to touch it. But for optical fiber, you can touch it because this is a light and it is not hazardous for the human. They isolate one electronic circuit from another, okay, still passing data. They can react to light and change it to electronic data. Remote control devices also. We use this technology in the remote control for your TV and all, okay? So we use this optoelectronics. So these are all advantages, and we discuss about some different kind of optoelectronic devices in this node basically. So what we covered, you can see we have covered, guys, here ICs. Then we discuss is classification, advantage, disadvantage. When we discuss the optoelectronic devices, introduction, optoelectronic devices, optical communication, advantages, and summary basically. So this is all about this chapter, notes, you can say, ICs and the optoelectronic devices.